What's happening, y'all? Welcome back. In this video, we continue our discussion of how to use logical data in MATLAB by introducing a concept known as relational operators. We're going to start our discussion by looking back at the general framework, in other words, a 10,000-foot view of logical data in MATLAB. To do this, let's go ahead and click on the small question mark icon up here on the MATLAB tool strip. That gets us to the documentation. If we go over to the category known as MATLAB, that's the language that we're studying, we're going to go to Language Fundamentals and then go to Data Types. Remember that MATLAB claims that there are fundamental MATLAB classes or data types that we use. Here we see 16 array-based data types that are done on the left side of this tree, and then one scalar base for a 17th fundamental data type. So far, we've been talking about logical data, which is ways to store zeros for false and one for true. Remember that we said that logical data is used for 4 different purposes in MATLAB. The first one is to perform logical operations. We've just spent a number of videos investigating what that actually means and how to do that. We're going to move on to the second of those in this sequence of videos, which is to perform relational operations. To get started with our exploration, we're going to go to the MATLAB documentation search bar and type in relational operations. That will get us to a result page, the top one of which is titled Relational Operations. Notice when we click on this, MATLAB gives us relational operators are used for value comparisons. We can read that first line. Relational operators compare the elements in 2 arrays and return logical true or false values to indicate whether or not the relation holds. They say that for more information, we can see the array comparison with relational operators. We're going to click on that in just a moment. Remember, we were talking about logical data used to do one of 4 purposes. We're focused on the second purpose, and we see these operators, the equality operator, the greater than or equal to operator, the strictly greater than operator, less than or equal operator, strictly less than operator, inequality operator, in other words, not equal to operator, which is the not sign and then the equal sign. And then there's 2 functions here. We'll talk about those in a later video. The point of this conversation, though, is when we output the results from these operators, we're going to output that result using the logical data class. That's exactly what we're saying here. Logical data is used to perform relational operations. In other words, we're going to input 2 different quantities, check the relationship between them. Are they equal? Are they greater than or equal, less than or equal, etc., etc., etc.? And then we'll use logical data to capture the output of those tests. In other words, if the relation holds, we'll say that that's true. We'll store that as a logical 1. If the relation doesn't hold, we'll say that that's false. We'll store that as logical 0. This gives us some idea of what relational operations are. Let's go ahead and see the array comparisons with relational operators documentation page to learn more. Here we see that we can use relational operators to compare operands quantitatively using operators like less than, greater than, not equal to, etc. Then we go down and we do some examples to demonstrate how these work. So specifically, MATLAB is setting a 2 by 3 matrix A and then a 2 by 3 matrix B. And then it's checking where are the elements of A less than the elements of B. Notice that 2 is less than 5, so that relation holds true in entry 1, 1. MATLAB produces a 1 in that position. 4 is less than 5, that relation holds true in entry 1, 2. MATLAB returns the output of 1 in entry 1, 2 because that relation holds in that position. On the other hand, 6 less than 5 is false, so MATLAB produces a logical 1 in that position. We go down to the bottom row, 8 is less than 9, that's a 1. 10 is less than 9, that's a 0 because it's false, and then 12 is less than 9 is also a 0 because it's false. In other words, when we check the relational operation A less than B, MATLAB does an element by element check and then reports the output using logical data. Notice at the top of this page, MATLAB gives us a handy table which includes the symbol we're going to use for our relational operators, a corresponding equivalent function that we can use to accomplish the same task, and then a quick description of what those operators or function equivalents do in relational operations. Moreover, if we scroll down to the bottom of this page, notice MATLAB will give us the see also recommendations. Let's use the EQ page for equality operations. MATLAB says EQ, the function, is equivalent to the equal operator, and that is used to determine equality. Here we see that the syntax to call this operator is A equal B, or we can write EQ open parentheses A comma B. Left operand of the operator is the first input of our function. The right operand of our operator is the second input to our function. Let's scroll down a little bit. We see in the description of this equality operator, when we write A equal B, this returns a logical array. In other words, we're using logical data to capture the output. The elements of that array are set to logical 1, in other words, true, in each position where array A equals array B. Otherwise, the elements get logical 0. In other words, it's reporting a false for that test of equality. I'll let you read the rest of this description so that you get an idea of what's happening here. Let's scroll down to some examples. Notice we can test the equality of two vectors. In this case, we're testing complex data, and we're testing whether or not to see if one complex number is identical to another complex number. Here we see when we compare entries A and B, the first entry is not the same, second entry is not the same, the third two entries are identical, and we can see that based on the results of this relational operator that outputs a logical array. Notice there's a lot more to relational operators than just numerical tests. We can use this relational operator to find characters. We can find values of a categorical array. We can compare floating point numbers, which is kind of an interesting concept. Compare date time values. Date time is a data class in MATLAB to actually store times using MATLAB variables. We can use the relational operator to test if two times are identical. And then at the bottom of this, we see that there's a discussion of inputs arguments. We're going to go through this discussion in great detail. The other thing that I'll say is that in these introductory videos, we're not going to focus on comparing any other data types but numeric data, i.e. to keep our introduction to relational operators simple, we're going to focus on just taking two variables that are stored as numbers and then using the relational operators to see, are these numbers equal? Are they not equal? Is one of them less than or equal to the other one? Et cetera, et cetera, et cetera. The point of this is once we know how to do those relational operators on numeric data, we can use the same ideas to expand our use of relational operators onto other types of data in MATLAB. To start with, we're going to focus on the equal to operator, which is the double equal sign. To get to that, I just hit equals once, equals twice right next to each other. That is a binary operator, which means when I type the double equal sign, I expect something to the left and also an operand to the right. Two inputs. In other words, it's binary, two inputs. Next, we're going to go to the not equal to operator. To get to that, I hit shift tilde. That's the one right above tab. So it's shift turns that to tilde. And then right after that, we put an equal sign. That tests whether or not two things are unequal. If they are unequal, it produces a 1. If they're equal, it produces a 0. Again, that is a binary operator because there's an operand on the left and right hand side. The equivalent function is NE. Not equal to. We also have the strictly less than symbol. That's the sideways caret. That one is right next to the M symbol. So if I hit shift and then that little sideways caret, that test is going to see if the left operand is less than the right operand. And that's a strict equality. They cannot be equal. We could also have the less than or equal to, in which case we use the same left caret next to the equal sign. Notice that less than functionally is LT, less than or equal to is LE. Also, when we're thinking about operands, the left operand of each of these operator is the first input to the function, and the right operand is the second input to each of these functions. Just like we have less than and less than or equal to operators, we also have greater than and greater than or equal to operators by just shifting the carets around. In other words, instead of going shift the button right next to M, we could go shift the button right next to the question mark, which is this one here, and that would get us the strictly greater than symbol combined with the equal sign that's greater than or equal to. In each of these situations, when we test the relationship between two numeric variables, the output of that test is going to be stored using logical data. In other words, it's going to be stored using the logical class in MATLAB. That relates back to the idea that we can use logical data to perform relational operators. The last thing that we discussed is that when we're using these operators, the left and right operands have to be of compatible sizes. If we go ahead and go to the search documentation and type in compatible sizes and then push enter, the first result is compatible array sizes for basic operations. If we click on that, MATLAB goes through a discussion of what that means. We're going to cover that in detail both in this video and in the examples that we do as we run through this. The point is I want to show you how to access documentation, because one of the fundamental concepts in this course is you can learn to teach yourself MATLAB. To do that, let's use the documentation appropriately. In other words, let's get a sense of where we can find answers to the questions that we have. A quick synopsis of this documentation for compatible sizes says, the left and right operands are of compatible sizes if they fit into one of 5 categories. 1, either they are both arrays of identical sizes, in which case the left input is m by n and the right input is the same size. The output, of course, would be an m by n. Second situation is if we have one of the operators is an array and the other operator is a scalar. In this case, the output would be the size of the array. Third compatible size is if we have an array and then a column vector with the same number of rows. Fourth compatible size is an array and a row vector with the same number of columns. And then fifth compatible size is if we have a column vector and then a row vector in the other argument. All of these compatible sizes output an array of size m by n. The point of relational operators is that the input will be numeric data and the output will be stored in a logical array of size m by n. With that, let's start our examples of how to use the relational operators and how that relates to logical data. That's exactly what we'll do in the next video.